So yes, again, thank you so much for having me. I appreciate the opportunity to speak. And all right, let's get started. So this is Containers Continued. That's the title of today's session. I am Anthony Nocentino. You have my previous bio, John, from when I was self-employed. Over the summer, I changed jobs. I am now a principal field solution architect at Pure Storage, where I focus on SQL Server. More generally, I specialize in system architecture and performance. So there's my contact information. I'm on Twitter a whole bunch. So there, if you don't follow me on Twitter, please do so. It's kind of my main way to interact with the community, things like blog posts, speaking events, and things like that. I'm a Pluralsight author and have tons and tons of content out there on containers and Kubernetes and Azure and things like that. If you want access to that content for free, let me know. I can get you free trial access codes. You can have access to all of my stuff out there. I've written a couple books with my great friend Ben Weissman, who spoke for y'all a little earlier this year when he had to step in for me to take over a session, and he taught y'all how to deploy SQL Server on Kubernetes, which is the latest book that he and I wrote together. Secret, we're in the process of updating the Azure Arc book right now. Hopefully I'll get that done this week. So the title of this session is called Containers Continued, right? And it's really kind of a build on of another session that I've done called Containers You Better Get on Board. If you want to watch that session, there's a link to that session there, kind of the foundational layer for what we're going to talk about today. But don't worry, I'm going to make sure that we can kind of have a good, meaningful conversation without having watched that other video, but you have the access to that content now if you want to dive a little bit deeper. Because what today we're going to focus on is how to build containers for more production-ready systems. Like, what do you need to think about as you go forward and look at how I can use SQL Server, or excuse me, use persistent state applications like SQL Server inside of containers. So that's kind of the first stop, is how to store persistent data in containers, and looking at how that's built and some of the tricks and techniques of making that work well. Now, we'll talk about some security constructs, non-root containers. We'll talk about why root containers are bad and why non-root containers are good, and how that impacts what you're going to look at when you go into production with a container. It's just more general about containers, but we're going to be laser focused on SQL Server today. And we're going to look at how to build custom containers. We're going to work in some SQL Server features and some configuration. Again, kind of building that container for specifically for your environment so that you can deploy it more quickly and more easily. Another big thing is, how do I get my data into a database that's inside of a container? We'll look at some good ways to do that and some bad ways to do that in our session. We'll talk about the pros and cons and why, and then we'll get into some container performance concepts. So tons and tons of content to get through today, team. If you do have any questions or comments, you can put them in the chat. And John, if you want to surface them up at an appropriate time during the session, that's fine. We can get those questions answered, and then we'll obviously have a Q&A at the end. We'll hang out for a little bit. All right, so let's get started, team. Let's talk about how containers store data. This is kind of my general diagram of what a container looks like. A container is going to contain the binaries and libraries that describe or that are the application that you want to deploy, right? I want to start up an application inside of a container. And the way that I'm able to move that around and exchange containers with you and have Microsoft exchange containers with me so that I can run SQL Server wherever I want is via a thing called a container image. A container image is read-only. So if I start a container, I'm going to pull the image and I'm going to start it up, but it's read-only. So where does the data that goes that I need to write to or change, where does that go inside the life cycle of the container? Well, by default, that goes to a thing that's called the writable layer. So as I change data, right, from my application, it's going to land in this writable layer. And it's the responsibility of my container runtimes, things like Docker and Containerd, to present both the container image, right, the stuff that's in the container, and the stuff that I've written or even changed from the container image, that'll get written into the writable layer too. It's up to the container runtime to present that back to me as a single file system so that my application can make sense of that, right? And we'll dive all into gory detail how SQL Server looks in that model in a few minutes. But there's a challenge with this, right? And this is kind of like the ephemerality of containers. People are like, well, I don't want to store stateful data inside of a container because that writable layer has the life cycle of the container, right? Container image is the thing that I exchange. A container is a running container image combined with the writable layer. If I delete the container, the writable layer is going to go away. And so the data that's in that writable layer will be gone too, right? And we're data professionals, right? Cloud data driven. So we have data. That's kind of our job as DBAs and data professionals, is to keep data around. So let's look at how we can leverage persistent data inside of Docker, right? Or just in containers in general. So if I start up a container from a container image, I will always have a writable layer, right? That's where things will go to that are getting changed inside of a container. But what I can do with Docker and most container runtimes is I can present a volume at a fixed location in the file system. So for example, a SQL Server running inside of a container will expect its data to be in a directory var opt MSSQL. So that's the path to where that data is. If I put a volume at that location, well, as I change data, that data will be getting written into the volume rather than into the writable layer. Now, other parts of the file system, like slash Etsy or anything else that's not var opt MSSQL, will still get written to the writable layer, but I might not care about those things. And those things can be deleted when the container goes away. So if I delete this container now, that container will go away, the writable layer will go away, but the stuff that's inside of the volume is still there, right? It's still accessible for me. It's on my actual base operating system. We'll see where it lives when I get into the demos. But what I can do is I can start up another container now, or maybe a new version of SQL Server or a new cumulative update, things like that. I can start out the container. SQL Server is going to start. It's going to look at var opt MSSQL, and it's going to see that the data is still there, and it's going to work just as we would expect an application to work. And one of the key things I talk with folks about when I talk about containers and deploying inside of Kubernetes is people really don't care if SQL Server is online. What they care is if they can get to that data. And so as long as I can put a container there, I can get access to the data. And so that volume has a life cycle that's independent of the container. We're going to see this in practice when I get into all the demos. And so let's look a little closer at what volumes are. We're going to focus on Docker data volumes today, but any of the other container runtimes support this type of construct, being able to attach persistent storage to a running container. The Docker data volumes are a construct of Docker that are generally going to allocate storage from the local host. So on the right here, you see I have SQL Server containers 1, 2, and 3 up and running. I can allocate a volume from the physical or virtual machine, either one, from that system, and expose that into the container at that location that we talked about earlier, var opt MSSQL, or any location inside of the file system that I'd want to have persist. And so there you can see I have the volume is just named SQL Data 1. That's going to be attached into the container. SQL Server starts up and starts writing data into SQL Data 1. Now, we can leverage we have the ability to leverage these things called volume plugins to enable remote storage scenarios, but that's kind of dead. Like the development of volume plugins has kind of fallen behind. I've done a bunch of research to see if there's any activity around there. And it seems that most of that's kind of gone away for Docker specifically. So if you see some stuff around volume plugins, you might want to shy away from that to get access to remote storage. When I say remote storage, I'm talking about things like SANs or NFS, other storage that's not local to the operating system that you're running Docker on. And so what I'll do for most scenarios where I want to access remote storage is I'll just handle that at the operating system level, right? I'll just attach a volume at where I want to provision storage from onto the base operating system to get access to that remote storage rather than leveraging Docker to coordinate access to that remote storage. Now, what you can do when you allocate volumes is you can pre-populate content. So I can put stuff in SQL Data 1 there and do things like have additional volumes for backups, right? And so there I can have backups or even database files inside of those data volumes already, or even application code and scripts that I'd want to have access to inside of the container. So when my container starts up, I can have backups in there already. I can have the scripts in there to restore those backups and then just run that code. I don't have to ship that as part of the container image itself. So if you want to dive into specifics about Docker storage, I encourage you to check out that link there. So that's kind of the ideas behind data persistency inside of containers. Let's take one pit stop and talk about some security concepts before we get into the demos. So before, I think it was SQL Server 2017 or maybe 2019, mid-life cycle, one of the cumulative updates, Microsoft switched the container from running as the root user to the non-root user. And due to the concepts of isolation inside of the container, you might be thinking, well, if it's isolated, it shouldn't really be a security issue. And why would I be concerned about a container running as root? Well, it actually, if I have a container and an application inside of the container running as root, it exposes the underlying operating system almost completely because Docker commands are privileged. So if you can run a Docker command, you basically have sudo or root level access to the underlying operating system. And so I can do some stuff, right, when it comes to accessing the underlying OS. In addition to Docker commands being privileged as to why that's an issue, Linux uses user IDs and group IDs for permissions. So if I have an application that's running as user ID 0 inside of a container, well, for the things that it can see inside of the container that it has access to from the base OS, it'll have privileged access to. And so one of the common scenarios that we talk about is, since I can run Docker commands to start a container, I can start an application as user ID 0. Well, I could attach to /etc, which is the configuration directory for a Linux system, and do whatever I want, right? Because the security barriers or security permissions inside of Linux are based on user ID. My application's running as root, user ID 0. I have privileged access to whatever directory I want now inside of the operating system. So super, super bad. And so we don't want to have anyone to be able to do that. So today, when you get a container from Microsoft for SQL Server, it's going to run as the user MS-SQL, right? And so that means you don't have to do anything if you're using Microsoft's container image. But I'm going to make the case in a few minutes that you're going to need to build your own container image. You're going to want to do that. And to do that, we're going to make sure that our application is running as non-root. So that means we have to do some stuff when we build our container image to make sure that it doesn't run as non-root. Microsoft's official image, non-root, and the container images that we want to build are we want those to run as non-root as well. So if you think, well, why would I want to build my own container image? Well, you can build once and deploy many, right? That's really kind of the key concepts behind containers and container images. Is I want to build this thing, and then I want to deploy that quickly and repeatedly in code. And so what can I do with building my own container image? Well, I can add customizations, right? I can enable trace flags. I can add different things to the SQL instance that are specific to my environment that I'd want to ship to every single SQL Server instance that I stand up inside of a container, right? So it gives me that level of control over what's really going into the container, rather than relying on Microsoft to ship a container that has a configuration that I want. So that pushes that into my area or my control. Moreover, security. If I'm building my own container image, I can control the exact patch levels for whatever lives inside of that container, rather than having to depend on Microsoft to ship a container that's patched for me to consume. And if you go look at the GitHub repo for the SQL Server container, Microsoft maintains a GitHub repository with issues and things like that specific around the SQL Server on Linux container. And lots of folks comment on that a lot. How come you guys aren't patching the container and shipping that to us at a higher frequency, right? And so not that it's Microsoft, I mean, it is Microsoft's responsibility, don't get me wrong. But in the end, it's your responsibility if you're going to be running code in production in your platform to make sure that your things are patched, right? And so let's look at what it takes to build a container image, right? We're going to set up our environment. I'm going to break this down into a couple high-level steps, and I'm going to dive deeper into each one of those. We're going to set up our environment. We're going to install SQL Server. We're going to configure SQL Server, do some stuff, and then we're going to build the container image. And so when I say set up the environment, we're going to do things like add users, because we want to add a user to the container that's non-root for SQL Server to run as. We're going to add the app repositories that our SQL Server on Linux installation will come from. We're going to use a Debian container in our example today. You could certainly use an Ubuntu, or excuse me, we're using an Ubuntu container, so we'll be using app. You can certainly use RHEL or CentOS and things like that. Once we have the repository set up, we can install SQL Server. We'll maybe want to install some tooling and any other additional packages that we would need to go inside of our container image. Then once we have SQL Server installed, we're going to configure it with a tool called MS-SQL-Conf. That's going to set some values for how, like things like trace flags and things. And if so, I want SQL Server agent turned on. And then we're going to define some environment variables that can be injected into our configuration. And then we're going to build that container image locally. Now in the demos today, I'm just going to build it locally. But the next step, if you were doing this in production, is you push your container to a repository so that you could deploy that in your environment. And so when it comes to what you can configure inside of SQL Server, I'm going to send you to two different links here. That first link is the configuration, configuration touch points for MS-SQL-Conf, and then also the environment variables that you can use to inject configuration into your running container image. One of the analogies I like to make for MS-SQL-Conf is in SQL Server on Windows, you had the MMC snap-in SQL Server configuration, where you do things like set the service account, set your TLS certificate, what port SQL Server ran on, things like that. Well, there's no MMC console in SQL Server on Linux, nor in a container. And so anything that was available in that previous tool, SQL Server Configuration Manager, is implement it in MS-SQL conf. And so that's kind of the touch points there. We'll look at that in a few seconds. So that's what we're going to do now is we're going to look at a Docker file that's going to describe our container image. We're going to build that container image together, configure it, and then deploy custom image as a container. So let's get into some code, team. All right. So what we have here is I'm going to SSH into Docker host. That's a Linux VM running on my laptop here. And I have all of this code, like I said, it's going to be available to y'all to download and do this on your own. And so what we're going to do first is build a custom image. And to do that, we're going to work with a Docker file. Now we're going to bring together all of those things that I talked about, things like persistent storage, non-root containers, and then how to build a custom image all in this one demo here. So this will be a pretty detailed script to go through for Docker file. When I build an image, I'm going to start from another point. And I want to start from Ubuntu 18.04. And so what that's going to do is pull the Ubuntu 18.04 image and then start up an intermediate container and then run all of the commands that I've defined in this Docker file. And so when I go and execute a Docker build, it'll go through the sequence of steps that I've described in this Docker file and start affecting those changes to that running container. And then when it's done, it's going to give me a singular container image that I can start up containers from or push to a repo. And so let's walk through the steps of creating our first custom SQL Server container together. So the first thing I want to do is add a user. And I'm going to add a user with a specific user ID 10,001 for MS-SQL, right? And that's going to be what Microsoft expects, or by default, SQL Server to run at. So I create that user, SQL Server starts up, that user's available, it'll run as that user inside of the container. But all we're doing there is adding that user. But now I need to do the basic SQL Server on Linux installation steps. And so what I'm going to do first is I'm going to update my apt repository package list and then install some stuff, right? That I can now go and add the Microsoft repositories and GPG keys to my system so that I can go download SQL Server on Linux. So what I'm doing here is I'm combining several statements together into a single run command. So you can see first I'm pulling the key, then I'm adding the repo to my list, then I'm adding another repo to my list, and then I update my package repositories, and then I install SQL Server, which is going to come from this first repo, and then I install MS-SQL tools, which is going to come from the second repo. It's going to run all of that, or not run all of that. That's going to run when I do a Docker build. Now that I have all of that stuff installed and the app repository is configured and refreshed, what I want to do is actually get rid of all of the caches associated with all of that stuff and get rid of that so that's not part of my container image, because I want to keep my container image lean and mean, because the bigger it is, the harder it is to move around inside of a data center just due to its actual size. The next thing that we're going to do is create some directories inside of the container. So there I'm going to create the directory var opt MS-SQL, and I'm going to give the MS-SQL user ownership of that directory so that when SQL Server starts up as a non-root user, MS-SQL, it has the ability to read and write data into that location. The next thing that we'll do after setting up the file system is configure our instance. And so here's just some example commands of me using MS-SQL conf to set a setting. In this case, it's going to be turn the SQL agent on, and that's the required command for that. I'm going to piggyback another command, which is going to enable trace flag through 226. And so these are the things that I've decided that I want to have implemented on every SQL Server container that I start up based off this image. The default container does not have, for Microsoft, the official container doesn't have these settings. And then I'm going to tell Docker to expose my application on 1433. And now here's where we get an interesting thing. Everything before here ran as the root user, which makes sense. I have to install packages. I have to run as root user. To change the configuration of my SQL Server, I'd need to run as the root user, have privileged access. But now everything after this command is going to run as the user MS-SQL. And what are we going to do? We're going to start up SQL Server. And so this is the command that's executed when I do a Docker run. So it'll start that process right there, opt MS-SQL bin SQL Server as the non-root user MS-SQL. So let's go ahead and do that together. The first thing that we'll do is build our image. So I'll do a Docker build -t to give it a tag or a name. And then I'm going to have a local build context, which will look for a Docker file in the current working directory. So let's go ahead and run this code here. And what that will do is run all of the steps that I've defined inside of the container. So remember, from Ubuntu 18.01, then I'm going to add a user, and then I'm going to update my packages and install some base packages, and going through all of the steps that I just walked through. So those commands are actually being executed in intermediate containers, and then finally building a container that I can start applications from, and then tagging it with a tag of SQL image demo 1 latest. And so once that's built, I can then start containers from that. Now, if you noticed, that ran really fast because I ran that code before, because I didn't want you all to have to wait for me to actually like install SQL Server and build a container. It takes a minute or two to do that. So when you do, if you do reproduce this demo, expect that to take a couple minutes. And so from there, I can start a container. So let's walk through the syntax of doing that. Docker run, accept EULA. I'm going to inject an environment variable here, MSSQL SA password, something so strong. I'm going to give my container a name. I'm going to set the host name inside of the container to SQL demo 1. And here I'm attaching a Docker data volume at var opt MSSQL. So remember, we talked about persistent data and things like that. That's where that data, or that's the volume that I'm attaching at this file system location. I'll show you in a few minutes where that data really is in my base OS. My container will be accessible on port 31433. I need to pick an easier port to say. That's extremely challenging to say. But inside the container, it's listening on 1433. So as I stand up multiple SQL servers, I have to change this port. But SQL Server always thinks it's running on 1433 inside of the container. So let's go ahead and run that there. Now, if you haven't worked with containers before, I now have a fully running instance of SQL Server available to me to work with on my laptop here in a matter of a few seconds there. I think that is still, as long as I've been working with containers, an extremely powerful concept to be able to do a deployment of a SQL Server that fast. So I want to confirm if the container is running, so I can do Docker PS to do that. So Docker PS is going to give me a listing of all the containers that are currently running on the system. I get things like the actual container ID, the image that it was built from, the command that started, and then also where I want to send traffic to. So 0.0.0 is all IPs on my laptop here, and I'll send traffic to 31433, and it's going to go into the container at 1433. And so just to test that out, I'm going to use SQL CMD against localhost because my IP changes every once in a while. So I'm just going to point it at localhost rather than a specific IP. That's where I want to send traffic to, 31433. And I'm just going to run a simple query to ask SQL Server for its server name. I already have a SQL Server up and running, and the host name sets the server name, SQL Demo 1. Let's see what version of SQL Server we got today on our Docker build. We're running 2019 CU14, right? Pretty cool stuff to see there. So with that SQL Server up and running, let's go inside that container because, well, I want, due to the process isolation of how containers work, I can actually start another process inside of the container and get a shell. And that's what we're doing here. So Docker exec, IT is short for interactive terminal. I'm going to get an interactive terminal SQL demo 1. What I want to do is attach to a process named bin bash. And I already ran that a second ago. That's why it errored out. So let's clear that out. And you can see I'm logged in as user MSSQL at SQL demo 1. If I do a PS minus AUX, you can see all of the processes associated with this container are running as MSSQL the user, so non-privileged, non-root user. The process that launched first was opt MSSQL bin SQL Server, which then kicked off 2 additional SQL Server processes due to the architecture of SQL PAL and SQL Server on Linux. We injected some configuration into our SQL Server instance with MSSQL conf. What MSSQL conf does is it sets keys and values inside of this configuration file here, mssql.conf. And so there you can see SQL Server agent is true, and that trace flag that we turned on. I injected some environment variables when I started up the container. So there you can see the one that I added. The rest come with just normal SQL Server or normal Linux operating system variables. And there you can see that the password is available as an environment variable. So I can also inject other configuration that way as well. We have a Docker data volume at var opt MSSQL. And you can see just a few minutes ago, see what the actual date is inside the container because it's UTC 1730. So just a few minutes ago, it laid out all of the things that it needed for the instance. So the data and log files to be here. the actual log files, application logs will be there. There's our MSSQL conf file and a secrets directory. I won't show you what's in there because it's a secret. Just kidding. It's like keys and things like that. If I look inside of MSSQL or var opt MSSQL data, we can see kind of the standard SQL Server layout. So master, model, tempdb, and things like that are all available to me inside of that location. And I've attached those as a Docker data volume. And so those things actually don't live inside the container. They live somewhere else. And I'm going to show you where they actually live on a Docker system. So if I do a Docker volume inspect against SQL Data 1, which is the name of the volume that I just created, it's going to tell me where that really is on the base operating system. And so that's going to be var lib docker volumes SQL Data 1 underscore data. And if I go look inside of that directory, what do I have? Anything that was in var opt MSSQL. That's all written into this real file system location. The container runtime is what manages kind of the switch or the mount into the container so that the container and the application running inside of the container think that's actually var opt MSSQL, but it's not. It's literally that location on the file system. If I go look into the data directory there, we can see that's where the real data lives, right? So I start up my container, I attach a volume at var opt MSSQL, it wrote a bunch of data there, and it's up to the container runtime to do kind of that mapping to bring that into the container for my application. So to remove my container, I can do a docker rm -f. That's going to shut down and delete the container, but my data is still there, right? It's still at SQL Data 1. If I go and I look in this directory again, oh wait, did I remove? Oh, darn it, I ran that. I did run that. Darn it. Okay, this removed the container, just to be precise. Container. Then I shouldn't have ran this so fast. This removed the volume. And so up until this point, the data still lives. And then when I run that command, this folder goes away, right? And all the data associated with that. So now if I look inside of the parent directory for that, I just have a metadata file that describes the configuration. So cool. So that's persistent data and how to build a container and things like that. Let's go and move forward and talk about getting our data, like our database data, into that container. And this is the most common question I get about this is, should I put the databases inside of the container image? That depends. Because the stuff that you put inside of the container image becomes part of that image and persistent part of the image. And so like, do you really want, this specific version of a database inside of the container image that you're going to start 10, maybe 15 different containers from? Maybe just a schema. I don't know. That could be a good idea too. But if you start putting in real data, like big data, like gigabytes, terabytes, whatever, well, that's going to present some problems. In fact, if I did a test, I think it was like 60 or 100 gigs. A SQL Server will crash, actually, if I put too much data inside of the container, because on container startup, anything that's in the container image is going to, once I try to attach that database, I'm going to change that data file. That data file is going to have to be copied out into the writable layer from the image, right? Or down to a volume. And if that takes too long, SQL Server can crash. And I think I have some screenshots of that crashing a little bit ago. So I strongly encourage folks to not put database data inside of the containers. So I'm going to show you some other techniques on how to make that happen. You can restore or attach a database on container startup, right? So I could start up my container and then I could just attach it, right? Because I could actually have that data already inside of a Docker volume and then just, create for attach and then point to the data files themselves. Or I could just execute a restore from a collection of backups that might live in a Docker data volume too. And we can do this a couple of ways. We can do it manually by just executing T-SQL against the instance, or automatically as part of the startup process. So I'm going to walk you through a technique on how to do that in a few seconds. But those databases that you want to attach or the backups need to be available to the SQL Server process inside of the container. They need to be able to read either the database files or the backup files to do stuff with. And as I indicated a few seconds ago, well, I can pre-stage those in a mounted volume, and those volumes could be local or remote. They could be on that physical system, or they could be mounted from maybe an NFS share or a storage network, things like that. And that's going to get you the ability to get larger databases into your containers much more easily. And so let's kind of look at the process, and how I do that. So on the right, there's kind of our normal pattern that we've been looking at for attaching data volumes. Well, like I said, I could have another data volume feeding backups into a container image, or I could have that same volume be attached by multiples. So I could share that if there's a stack of backups in there. I can't share database files and attach them because it's just, you can't have two SQL Server processes attached to a single set of data files because it takes an exclusive lock on the file. But backups, definitely you can do this with, and it makes a lot of sense. And so let's look at how we can automatically get data into our container. And this is where we're going to go through right now. So that when we walked through the Docker file a few minutes ago, I showed you the command that gets executed when the container launches, right? And that's was opt-in, I forget the exact location, but SQL Server. Like, it was the process that was getting started. Well, what if I call a script in that Docker file instead of calling SQL Server to start? And so the first thing that'll happen is I call this script. What that script will do is it'll check over and over again, hey, is this SQL Server online yet? Because SQL Server does take a few seconds to start up just to boot and get the process started. Then once SQL Server started, I then call another script to execute a restore or an attach. And so at that point in time, then I'll start reading the database backup or attaching that database and can go. And that way now I've kind of decoupled the stuff that I want to ship, the data, from the container image itself, but I do have an automated process to go and read some data in. And so let's go ahead and see that in action. Let's restore databases into our containers. We're going to jump over to demo 2 here. And I'm going to change directories. Go ahead and clear that out. Now, the first thing I want to do is I'm going to start a container and I'm going to attach a couple volumes to it. So Docker run, I'm going to jump down through the important parts here. I'm going to have another volume for SQL Data 2 for this specific demo. So it's going to allocate another Docker data volume and it's going to mount that there. And then I'm going to attach a directory where I have a bunch of backups in on my base operating system. So that the stuff to the left of the colon is on my base OS. The stuff to the right of the colon is where it's going to show up inside of the container. So you can see the difference here. This is when I just give it a name like this will create a Docker data volume. And this is called a bind mount, which is going to mount a fixed location on the base operating system. So let's go ahead and see that in action. And we're going to run my SQL image demo 1 from the previous demo. You'll see tons of demonstrations that do this, and this drives me nuts. I shouldn't be so mean about that, but this I don't think this is a great solution. Lots of folks will copy backups into the container, right? Why would you want to do that? You're going to waste time and space, right? So if I have a stack of backups on this base OS, which I do, right, in backups here, why would I copy those into the container? And if this is of any healthy size, then inside the container, I'm going to need that much space. And then execute the restore, or I have to change the permissions so that the backup is available to the non-root user. And then I'm going to run a restore script. Why would I do that when I could just do this? I attach a volume, and the stuff that's available inside this directory, so there's my database backups, is available inside the container at /backup. And so now I don't have to move those bits and bytes. I just get access to those because I'm attaching them as a bind mount. And that's what we did when I started the container and defined that second volume. And then inside or outside of the container, I can just blast some T-SQL against the instance using SQL CMD, and I can run a T-SQL script and restore my database, right? And so there we can see the database restored in just a few seconds, a real small database there. So that's kind of the manual way of getting data in, right? You can see my system databases and then the user database that we just restored. That's the manual way of doing that. So let's go ahead and delete that container and the data volume associated with that, and look at an automated way of making that happen. So this is a second Docker file in the demo 2 directory. And I'm going to jump down through the important parts. You've seen all this first stuff before. It's all the same until I get to here. What I'm doing here, after I install SQL Server and configure it, is I'm going to copy some scripts into the container. I could not actually have them copy in. I could leave them out in the bind mount and run those, but I just wanted to show you an alternative technique here. So I can take those scripts and stick them in the container. I'm going to mark those scripts as executable, expose SQL Server on 1433, and then I'm going to switch user. And then what I'm going to do here is run 2 commands when I start up the process or start up this container. I'm going to call this script configure DB, and then I'm going to launch SQL Server. Let's go look at what's inside of configure DB. So these are copied into the container. So inside of configure DB, I'm not going to walk through the code in gory detail, but I'm just going to focus on a high-level process. I have a loop that's looking to see if SQL Server is online. If that process returns 0, break. If it doesn't return 0, wait for a second and then iterate. So that's how I'm going to check over and over again to see if SQL Server is ready. Break out of that loop. If SQL Server is ready to go, then I'm going to print out that I'm restoring the database, and then I'm going to call my restore script. And so what this is going to do is when I start the container is run this script, wait for SQL Server to start, and then once it's started, it's going to run that script to automatically restore that database. And so let's go ahead and do that. So this is all defined in the Docker file. I need to build the container. So Docker build -t SQL image demo2 in the local build context in the demo2 directory. I pre-built that so we didn't have to sit through that process again. So that took just a couple seconds. But now when I run this container, it's going to do that process for me automatically. So I'm going to start up that container off our second image. And then what I'm going to use here is one of my favorite commands in Docker is Docker logs. Is I'm going to use Docker logs to get all of the logs associated with this container that's running. And I'm going to follow those. So it's kind of like a tail. It's going to constantly read what's being output to standard out. And there we can see once SQL Server comes online, it becomes available. That's where my code kicks in, attempting to connect the container, SQL Server ready, restoring the database, change context, test DB1, automatically restored. And so that process now, I could package this up and give it to a developer, and then they could start the container and they could either attach automatically or restore a database automatically. And you could take this script, the configure DB script, and extend it even further. This pretty simple example is maybe there's a stack of backups that I want to use, and I could maybe use DBA tools to just point at a stack of backups and restore all of those into the container for me to have access to. So you can extend this as far as you'd want for getting access to that data. Let's look at what's up and running. Here we see test DB1 is available on our container, and I didn't have to do anything. I just started up the container and I got that data available to me. But it's all dependent upon having access to the backups. So let me hop into the container again. We're going to launch bash shell. If I do an ls/backups, those files are available to me inside of the database or inside of the container because that process, that SQL Server process, needs to get access to those files. So that's kind of the key on how that works there. So let's go ahead and exit out here and clean up from this demo. Oops, definitely want to keep that there. All right, so that is restoring databases inside of the container, both manually, right? With SQL CMD, I just ran some T-SQL against the instance, but the backups had to be available, and then automatically when I started up the container. Now, for our final topic that I want to get into, after building our own container images, getting access to the data, is understanding performance concepts inside of the container or inside of running SQL Server inside of containers. Now, when I talk about performance concepts, I want to look at running multiple SQL Server and Linux containers on a single operating system. And I want you to understand how SQL Server running inside of a container sees the resources, and also we as administrators has to manage those resources. And so let's look at the details about that. SQL Server and Linux does not support named instances, right? So in Windows, we had named instances. We could run a bunch of different instances on a single SQL Server VM or physical host. SQL Server and Linux doesn't support that, but you can get similar functionality by running multiple containers on a single operating system. You'll just deploy them with unique names, so unique container names, unique storage, unique network ports, right? Because I need to be able to attach an application to it, and I need to be able to store my data in a unique place. And so if I want to do something like this, I can do that very easily inside of containers that just start each container on a different port. So there's SQL 1 is on 31443, SQL 2 is on 31444, and so on. And each is attached to a unique Docker data volume for its data that persists my application data in, right? But there's a caveat here. Resource management is your responsibility. When you did resource management running multiple instances of SQL Server on Windows, you kind of had a safety net of Windows could effectively communicate to SQL Server that it was under memory pressure and vice versa, right? There was kind of some synergy there for memory management. SQL Server and Linux doesn't really have that. And then add in the process isolation of containers that adds a whole new wrinkle to the game. And we're going to dive into how that all works now. So let's get into some container-based performance concepts. Again, the key thing here is resource management amongst these multiple instances, your responsibility. Or mine, you can just call me. Because what a container really does is it shares the underlying operating system and access to its hardware. So things like CPU, disk, memory are going to be all of the resources that I'm going to get from the underlying OS. And all the containers by default are going to think they have access to all of the underlying resources available that the container is running on. So if I just started up SQL 1, 2, and 3, and my base operating system had 4 cores and maybe 64 gigs of RAM, SQL Server 1, 2, and 3 will think it has access to all the cores and all of the memory, which can put us in some interesting situations. Docker and pretty much any container runtime, and even Kubernetes, gives us the ability to do to assert resource controls on containers with a thing called control groups or C groups. Right? And so that allows you to control what an individual container has access to. And so we have knobs for things like CPU, memory, block IO, process IDs, and things like that. So we can put some resource limits around what each container can consume. What's interesting is it's also adjustable after creation. So if I need to choke down a CPU on an individual SQL Server container that's running because it's got hot and it's maybe consuming too much processor, I can do that, right? And there's a bunch of other resource constraints that are available, and it's pretty cool to see how you can control all of that. So I encourage you to check out that link there to dive into all of those. And so when we do need to set constraints or limits on how a container sees the underlying operating system, there's a couple things that I wanted to call out specifically with regards to how CPU and memory work and how SQL Server sees this, right? So for CPU limits on a running container, I have a couple of different ways that I can assert controls: CPU sets, CPU limits, and CPU shares, right? CPU sets will limit access to specific processors on the underlying OS. So I could say, SQL 1 only has access to processors 2 and 6, or whatever it is that I want it to have access to. I can put an upper boundary from percentage standpoint with a limit, and that's going to influence the scheduling across the cores inside the box, or shares, which are basically limits that kick in when CPU starts to get constrained. All of these different techniques, though, rely on the scheduler of the base operating system to allocate access to the CPU, right? If you think, what does that really mean? Well, every single one of these containers will see all of the CPUs in the system. So if I say, you know what, SQL 1, you only have access to 1 total core's worth of processor, right, with a limit. SQL 1 is still going to see all 6 cores, but the underlying base operating system will schedule the workload from that container onto a total of 1 core's worth of CPU. Similarly, with CPU sets, if I just say CPU 2 and 6, SQL 2 will still see all of the cores, but it's just going to have access to 2 and 6, and it's up to the underlying operating system to affect that from a scheduling standpoint. So that impacts a lot of things when it comes to how SQL Server sees CPUs and does things like generates plans and does things like degree of parallelism. That can put you in some unique situations from a performance standpoint. I've been working with the product team specifically about some guidance on this. And so once I know how they want to advise us there, I'm going to share that with the community. Memory limits will limit access to memory. So if I say SQL 1 has access to 8 gigs, it has access only to 8 gigs, right? It won't see all of the memory because it's not addressable. It'll actually limit it down, and it'll have access to just what I say it has access to. There's another knob inside of SQL Server due to the architecture of SQL Server and Linux, where SQL Server process will only have access to 80% of the memory that's available to it. So if I said SQL 1 has access to 16 gigs, and when it starts up, it's going to have access to about 15 and change, right? Maybe a little bit less than that, maybe like 16 and change, 80% less of 16. This is me trying to do math on the fly. I shouldn't do that. And so there's two wrinkles to the equation there when it comes to memory management, things like that. And this will become very clear when I do it in the demos here in a few minutes. I'm going to highlight both of those. Now, any configuration performance best practices, I encourage you to check out this link here because all of the SQL Server and Linux performance best practices apply to running SQL Server in containers. All right. So I'm going to jump ahead into the demos. The only slide I'm going to skip is talking about monitoring, but I'm going to dive into that in the demo. So I'm just being mindful of how much time we have left here. So from a demo standpoint, we're going to look at defining limits, looking at how SQL Server sees the host hardware, kind of all of those things I just talked about. And then we're going to use a command called Docker stats to examine some performance. So let's dive into our third demo. This is probably my favorite demo. So let's go ahead and switch folders here. And we're going to start up a container. One of the things that I wanted to introduce here is, what if I just want to run a container and maybe I have to reboot my laptop? Well, this restart parameter, my computer starts back up and Docker starts back up. This particular container will then just start back up unless I stopped it. If I do Docker stop, it'll stop that container. It won't restart it. And so that's a good way to make sure that your SQL Server will restart if you have to restart your base operating system. We're going to use our first image from our very first demo, and let's look at what's going on inside of the container. So our container's up and running, and I'm going to ask our SQL Server for what it sees from the base operating system in terms of CPU count and memory. Well, SQL Server sees all 4 cores and only 12 gigs of RAM. If I do a free minus M on my base OS, I have about 16 gigs of RAM inside of the system. So this is how bad my math was when I was talking about this a minute ago. So 80% of 16 gigs is 12 and change, and then 4 CPUs. So if I look at LS CPU, I have 4 CPUs in my system, right? So SQL Server by default, if I don't put any limits on the container, it will have access to all of the cores and all of the memory. If I start up a second one, that second one will think it has access to all of the cores and all of the memory. Okay, that same code's in there twice. Interesting. I'll have to clean that up. Now let's use Docker stats to see this from a Docker point of view. Docker stats gives us the name, how much CPU is being used, how much memory has been allocated inside of the container, and then the upper limit that it has access to. So just about 16 gigs, percent memory, and then network.io and block.io. That's a pretty cool tool there to see what's going on. So now let's start up another container with some limits. I'm going to limit the 4 gigs of RAM and access to 1 CPU. Let's go ahead and run that there. See that I have those 2 SQL servers up and running on 2 different ports, ending in 3.4, ending in 3.3. If I ask that second SQL server that I started up how it sees the underlying OS, it still thinks it has access to all 4 cores, even though it's going to get access to 1 core's worth of CPU, and it has access to 3 gigs of memory. So I limited it to 4. 80% of that is 3, right? That's what SQL Pal sees. The container itself, if I do a Docker stats right now, the container itself thinks it has access to 4. It's just the SQL Server process running thinks it has access to 80% of that, right? So let's go ahead and start a workload inside of SQL 2. Yeah, SQL 2. And with that workload up and running, I'm going to background that task and we'll do a Docker stats again. So this individual process has access to 1 core. It's using a pretty good chunk of that 1 core with the workload that I have up and running, about 70%. I'm going to switch to another window here while that workload is running and Docker stats is running. And I'm going to reduce that second container, SQL Demo 3B, to having access to only half a core. Jump back here. You can see it goes from the mid 70s to about 50%. Let's choke that down even further to 0.1. So real time, I'm doing this while that workload's running. That's down to just about 10% of the CPU that's available to it from the base OS. So it's pretty cool to be able to affect that change in real time against the operating system or against the workload in that operating system. Now, oftentimes from a monitoring standpoint, people ask me like, well, how would I get a view of the bigger picture of what's going on that individual system? Remember, containers are just processes running on an operating system with some boundaries thrown around them so that they think they're the only thing running, right? Because when I did a PS inside the container, all I saw was a SQL Server process. Well, they're just processes, right? So I just did a process listing on the base OS. So this is on the actual Linux box itself. And here we can see both of those SQL Server instances running on the base OS. We can see the amount of CPU, the amount of memory associated with that. And so I could just monitor these processes to get a feel for what the actual consumption is across the whole OS, and then obviously inside of each individual container. So that's a wrap for that demo. Let me go ahead and clean that up and maybe make my get my processor fans to turn off after running that workload. Others have a tendency to kick on when doing that part of the presentation. So just to kind of review what we've talked about, kind of a big kind of swath of different technologies and techniques on working with SQL Server and containers. But this is really what I think is the next level of things after doing your first Docker run and learning how SQL Server and containers works. These are the things that I think are super important as you kind of move forward into the next level of working with containers, focusing on storing persistent data, non-root containers, building custom data images, right? And getting those features and configurations that you want in your own container that you can start up with so you don't have to configure them each and every time you start up. Talk about getting data into your containers and the various techniques on doing that. And of course, container performance concepts, which are super important when you start running multiple containers on a single base OS. So if you need more information, please feel free to reach out either via Twitter or email. I blog pretty frequently at my new blog location there. I moved it from Nocentino Systems to Nocentino.com when I changed jobs. I will put this presentation on my GitHub repo in a matter of minutes once we wrap up. So you'll have access to both the PDF for the presentation and also the deck. And I'm pretty sure the presentation will be recorded. So I'll link to it there. And then if you want access to Pluralsight content for Linux, Kubernetes, Azure, whatever it is, hit me up and I'll get you free access to that content. You just shoot me an email at that email there, or a DM on Twitter is perfectly fine. So I want to say thanks to everyone for joining, and we will open it up for questions for y'all for the next few minutes.
That was an excellent presentation, Anthony. Thank you so much for putting this together.
Thank you. And thanks for having me. I appreciate it.
It's an honor to have you. We have a couple questions. I think one question Phillips asks. Phillips want to know, for example, if as a DBA using Docker container is cheaper than doing it completely on the cloud.
It's not. The way that Microsoft licenses its containers is the same as virtual machines. So if you have an enterprise license, you have the virtualization benefit, which gets you access to running as many containers or many VMs as you want. It's the same idea behind containers. I can run as many containers as I want as long as I license it appropriately. So if I just have 3 that I want to run, well, maybe I don't need to have an enterprise license and I just buy 3 licenses worth of SQL Server. And that's one of the things I've been asking the team about. And so for example, if I have a virtual machine of 16 CPUs in it and I install SQL Server on there, I have to pay for 16 CPUs. But even if I limit that VM to 4, I think I still have to license 16 CPUs. And I think that's going to apply to containers. I'm not a licensing expert. Don't get me wrong. I would strongly encourage you to talk to your Microsoft representative to find a good answer for that. But it's not cheaper. It's the same. Yeah, it's the same.
Yep. Which makes
Can I
sense.
pick the question?
Shoot. What's up?
Go ahead.
Great, thanks. Anthony, so when you do Docker, you're doing Docker on your computer, right? You can run a VM, of course, but you can have a run on your computer. So it's sort of a development environment. It's not really production grade, is it?
Right. Correct.
Right. So if I use developer edition for SQL, then all of these license things go away, right? Because developer edition for production, you don't have to worry about.
Correct. Correct.
Perfect. All right, cool. Thank you.
Yeah, it's I think by default in the container image, I think it's developer, but that's one of the configuration points with regards to MS SQL Conf and then also an environment variable is you can decouple that and inject which version you want when you start up the container or which license.
I have seen that option there, but I've been telling some of my clients, like, this is for the developers who don't have to worry about the license.
Yeah, developer, yeah, no worries. And that was one of the cool things is once they made that free, that totally makes sense.
Any other questions, guys, before we wipe up and go to the raffle?
Yeah, I have a question.
What's up?
Hello.
Hello.
Go ahead.
Yeah. So it's a continuation of my first question about the container versus using databases on Azure. If it's almost like the same price, then why would you use a container? Why not just run the database on Azure so that Microsoft will take care of everything that the DBA has to do, such as performance tuning, backup, and recovery, and everything like the DBA has to do. Because I feel like this way you'll have to spend money on the DBAs and also on the container. Whereas if you run a database on Azure, at least you only have one expense instead of two.
Yeah, I think to look at that question, when you're buying a PaaS service or a platform as a service from Microsoft like SQL DB or MI, you're basically shifting your DBA costs to them, right? And obviously your licensing cost, because you're shifting. You don't have to pay for a person to do backups and maintain a platform and all that fun stuff. That's you're just shifting that over there. But when you do that, you lose control over, or not you lose control, but you have less control over the platform and the tooling and things like that on the target side. And so that's really that's the paradigm there. And then further, if maybe you're in an industry that can't go to the cloud or you don't want to go to the cloud, and then that's kind of the line of demarcation, right? So that goes into all of that calculus, right? So it's not cheaper. It doesn't really change the way the support models for on-prem, with the exception of the platform, right? And so if you're all in on containers on-prem and you're doing things like Kubernetes for the rest of your application stack, then why not? But if you're already in the cloud and you're familiar with PaaS services, that's cool too, right? It's just another way to get store data. And it's kind of to the point that I made a few minutes or in the beginning of the presentation. Nobody cares if SQL Server's online. They care if they can get access to the data. And as a data professional, what's the best way for you to provide access to the data for your system? If you don't have DBA skills on-prem, then that's probably going to be a PaaS offering in the cloud. And so that kind of goes all into the business decision of where you store your stuff, right?
Okay, thank you.
Thank you.